All right, your data mining final is right around the corner, and I know the big question on everyone's mind is, what's actually going to be on the exam? Well, you've come to the right place. We're going to walk through the exact types of questions you can expect, so you can study smarter, not harder. So, think of this as your game plan for the final. We've actually structured this whole explainer to follow the exam paper, breaking down the big concepts question by question. The goal here is that by the end, you'll not only get the material, but you'll know exactly how to apply it when the clock is ticking. Okay, let's jump right in with question 1. This is a topic that's pretty much guaranteed to show up, evaluating how well a model is performing. And trust me, if you get this right, you're building a super solid foundation for the whole exam. It all really comes down to one essential tool. And here it is, the confusion matrix. Honestly, just think of this as the report card for our model. It tells us exactly where we were right and where we went wrong. So look at that top left corner, 100 true positives. That's a win. We correctly predicted yes. Then bottom right, 50 true negatives. Another win. We correctly predicted no. But of course, the other two cells, that's where we made our mistakes. We've got 50 false positives, we cried wolf and said yes when it was a no, and 25 false negatives, the ones that got away where we missed a yes. Getting a feel for this grid is absolutely crucial. So the first metric everyone jumps to is accuracy. It's super simple, right? It's just the total number of correct predictions divided by, well, everything. In this case, we're looking at about 67% accuracy. But here's a word of warning, and this is a big one for the exam. Accuracy can be really misleading. Just imagine you're trying to detect a super rare disease, one that only 1% of people have. A lazy model could just predict no for everyone, and it'd be 99% accurate. Sounds great, but it's totally useless, right? That's exactly why we need to dig a little deeper. And that brings us to recall, or you might see it called sensitivity. Now, this metric is a huge deal whenever missing something is really, really bad. Think about missing a fraudulent transaction, or even worse, a medical diagnosis. Recall asks a really important question. Of all the people who actually were a yes, how many did our model manage to find? Here, we caught 80% of them, which, is pretty solid. And finally, let's talk about the kappa statistic. This one is really clever. Why? Because it doesn't just look at how accurate we are, it compares our model's performance to just pure random guessing. So a kappa of 0 would mean our model is no better than flipping a coin. Our score here is about 0.31, which tells us, hey, this model has actually learned something real from the data. It's making genuinely informed predictions, not just getting lucky. All right, so we know how to grade a model. Now let's get our hands dirty and talk about how to actually build one. This is exactly what you're going to see in questions 2 and 3 of the exam, building classifiers. So let's pop the hood and see how these things actually make their decisions. Now, your exam is going to focus on 2 main types of classifiers. First up, you've got decision trees. These are basically just a smart flow chart, a series of if this, then that questions that lead you to an answer. And then you have naive Bayes. This one's all about probability. It weighs all the evidence and makes a statistical bet on the most likely outcome. So yeah, think of it as a logical, step-by-step flowchart versus a calculated, probabilistic guess. So how do you build a decision tree? Well, we use algorithms like Hunt's. And the core idea, the whole strategy, is to find the best possible question to ask at each step. And what makes a question best? It's the one that splits the data into the cleanest, most pure groups possible. You're trying to get all the yeses in one bucket and all the nos in another. And you just keep doing that, splitting and splitting again, until every group is as pure as it can be. All right, on to naive Bayes, which you'll definitely see in question 3. At its heart, it's all about Bayes' theorem. It looks at all the different pieces of information, all the features, and calculates the probability for each possible class. Whichever class gets the highest score wins. Simple as that. Now, why the naive part? Well, it makes this big, simplifying assumption that all the features are completely unrelated to each other. Now, in the real world, that's almost never true, but it makes the math way easier, and you'd be shocked at how well it actually works. Okay, so far, everything we've talked about is predicting a category, right? Yes or no, spam or not spam. But what if you need to predict an actual number, like a price or a temperature? Well, that's where regression comes in, and that's exactly what you'll be doing in question 4. Yeah, so regression is your go-to tool anytime you're predicting a continuous numerical value. It's not about putting things in boxes. It's about estimating a quantity. The example on the slide is perfect. You're moving from a classification question like, will this person click our ad, to a regression question, okay, but how much will they spend if they do? That's the shift in thinking, and that's exactly the kind of profit prediction problem you'll see on the exam. And what you get out of a linear regression is a nice, clean formula, just like this one from the exam paper. Don't let it intimidate you. It's actually pretty straightforward. Each X is just one of your features. Maybe X1 is how much you spent on ads, and X2 is your website traffic. The numbers attached to them are the weights. They tell you how important each feature is. So to predict the profit, all you have to do is plug in your numbers for each X and do some simple arithmetic. That's it. Okay. Let's pause for a second. Everything we've covered up to this point, classification, regression, that's all been supervised learning. That's a fancy way of saying we had the answer key to train our model. But what if you don't have an answer key? What if you just have a big pile of data and you want to find any natural groupings or patterns hiding inside? Well, welcome to the world of unsupervised learning. And our main tool here is called clustering. Exactly. So with clustering, we're not trying to predict a target we already know. We're going in blind, in a way. We're basically asking the data, hey, what's your hidden structure? How do you naturally group together? We're not telling the model what to look for, we're just letting the data speak for itself and reveal those natural segments. And the most common way to do this, your go-to algorithm, is k-means. And this process is just brilliant. First, you have to decide how many clusters you're looking for. That's your K. Then, the algorithm does this little two-step dance over and over again. Step 1, every data point gets assigned to its closest cluster center. Step 2, the center moves to the middle of all the points now assigned to it. And it just repeats that dance, assign, move, until the cluster centers stop moving and everything settles down. Okay, we're in the home stretch. To wrap things up, let's do a quick-fire round of the most important formulas you'll see on your exam sheet. Think of this as your rapid review flashcard session. Now remember, the goal isn't to memorize these from scratch, but you absolutely need to know what each one does and when you should be using it. First up, the Gini index. This is your go-to for decision trees. All it does is measure the impurity, or you could say the messiness, of a group of data. A Gini of 0 is perfect. Everyone in the group is the same class. The whole point of a decision tree is to make splits that drive that Gini index down as low as possible. Next, confidence. This one's from association rule mining. The whole people who buy diapers also buy beer thing. Confidence is super straightforward. It just asks, if someone buys item X, what's the chance they also have item Y in their cart? It's a direct measure of how reliable that rule is. Then we have lift. Now, lift is what tells you if your rule is actually interesting or just obvious. It takes it a step beyond confidence. A lift greater than 1 means that people are buying these two things together more often than you'd expect just by random chance. It tells you there's a real meaningful connection there. And RMSE, or root mean squared error. This is our report card for regression models. In simple terms, it tells you, on average, how far off your predictions are from the real numbers. It's kind of like the standard deviation of your prediction errors. And for this one, the goal is simple. Lower is always better. And that's it. That's your high-speed tour of what to expect on the final. You've got the toolkit now. You know how to evaluate, how to classify, how to predict, and how to cluster. The only real question left is, what problems are you going to solve with all this? Go get them, and good luck on your exam.